He's a nice kitty, so he's not a good at that.
Okay, my name's Gary Matsuoka, and we're here at Laguna Hills Nursery in Santa Ana. It's a Saturday morning, and today's topic is one of the more important ones on pruning. So first thing we'd like to, well, since I've got the tools laid out, might as well talk a little about them too. So generally, we have saws and loppers and things like that, but 99% of what we do is with pruners. And for the last 5 years, I've been using these German pruners that we'd have to retail for about $100. So we found a company that makes ones that seem to be just as good for a fraction of the price. This is a company that is a Japanese company. They designed them in Japan, but they manufacture them in China now. Because of the tariffs, I don't know what the price is going to do in the next few months. But this is their most expensive pruner, which I've been using, and it's like we sell it for $34. And then these are some of their pruners that are copies of famous designs from around the world. A lot of people copy the same design. These are $24. Same with this one, $24. And they've got the features you'd like in a good pruner in that they make the body out of aluminum, but they make the blades out of steel. Some companies make the whole thing out of the same material, so it's real cheap. If you drop them, they break. But this company makes better blades, like most of the good pruners are, with the aluminum body. And so for $24, this is their $17 pruner, which uses metal handles, but it still seems nicer. We had another company bring in their $20 pruner, and it felt like you had Lego toys in your hand because they just weren't fitting the fingers at all. Even though they were basically the same, they were too square. So we do like this company. They have a ratchet model, which I'm not a big fan of ratchet pruners, but they do have a ratchet model. And we do use snippers if you're handling a plant that's really stringy, then you use these little snippers. A lot of times I'll just get the scissors out and use regular old scissors for that. So that's the tools we use. I mean, if you have to go something big, I've cut down fairly good sized trees, trunks about that big, with just a hand saw. But rarely do I use that, especially since I cut down all my big trees. And loppers, I don't use these that often. I'd rather get closer to what I'm cutting. But if you have a branch that's too high to reach, that's pretty good. These we use to pick fruit. So this is a nice pick and hold. So I can go up there and pick an avocado off the tree and hold it. And then if you have hedges, we use shears. Okay, so that's the basic tools. I mean, a lot of times I'll just pick up something really cheap and use it. It's not the biggest deal in the world. And, 20, 30 years ago, I used the most expensive pruners, the Falco rolling handles. But to me, well, they're great pruners, but they're like you own a Porsche. So, every week you got to clean it and oil it because the specs are so sensitive that if you get any dirt on those things, it doesn't open anymore. It's like it's too fine tuned. You have to be constantly cleaning and oiling. So now I like the cheaper ones where I can, if I drop them somewhere, it's what the heck, it's not that big a deal. So one thing we like to talk about is how plants operate, so you know what's going to happen when you prune them. And generally, you think of a typical tree, it's a bunch of little tiny tubes going up from the roots to the top of the tree and tubes going from the leaves. So there's two separate systems in the plant. And I'm not sure exactly when plants became this way, because I think before the amphibians, way before the dinosaurs, but before the amphibians, plants were a little simpler. But once the dinosaurs are here, we had plants with more complicated vascular systems where the water from the roots goes up through the xylem. Whoops. Xylem. And then there's another system that's not connected to that one that connects from the leaves all the way back down to the roots. And that's the phloem. The phloem is the bark. The xylem is the heartwood of the tree. So the xylem becomes wood, phloem becomes bark. They're not structured the same. You can tell bark from wood, but that's what they do. So if you cut off all the bark on a tree and it doesn't reheal itself, the roots eventually starve because they're not getting nutrition from the foliage. So that's what the phloem does. It takes the nutrition that the leaves make, or the energy that the leaves make. Leaves make sugar. That's basically their job, is to make sugar. The water and the minerals comes up from the roots in the center of the tree, and then the leaves make sugar and they send it down the tree to feed all of the parts down below. So if you mess up the bark bad enough and it doesn't heal itself in time, then the roots die and your tree eventually dies. Might take a few years, but it eventually dies. So you need those systems intact. And plants don't really stretch much. The only parts of a plant that stretch at all, because people keep asking me, well, this tree has branches right here right now. How high will those branches get in 5 years? Well, the trunk doesn't stretch. So these branches that the tree makes here will always be there. Or they will be dead. So what plants do is the top of the branches are actually competing with the trunk for real estate on the trunk. So like on this tree here, you can see a dead branch sticking there, and the wood of the trunk, or the bark of the trunk, is cut. That's actually the bark and the wood from the trunk has cut off the circulation to this branch. So this branch died. This one, it looks like it's happening here too. So the material from the trunk is now covering the base of this branch, like it's cutting off its circulation. Now here's the branch that doesn't show that at all. You can see this branch, there's no collar around it choking it. So you can see what the tree's doing. It's laying new pipes all the time on the outside of it. The bark's laying on the out. Well, actually, both the bark. Okay, I got to draw this a little better. So you've got the heartwood of a tree, and we'll put the bark on the outside. And between the two is the growing layer called the, okay, I forgot the name. The layer between the bark and the wood is the, okay, I should have gone over that in my notes. But that's the only part of the trunk that's actually reproducing is right there. So this is where that's making new cells. It's making wood to its inner side and bark to its outer side. So the bark, the newest bark is just on the outside of that green layer, cambium. And the newest wood is just on the inside of the cambium layer, and everything's expanding. So both the wood and the bark are trying to cover this branch up. This branch has enough energy that it's staying ahead of the trunk. It's maintaining its space here. You can see it's not being covered up. But these down here, which are being shaded by those up there, they're starting to lose their way. So after a while, we expect all these to die and fall off, which is what happens on big trees. A lot of the bottom branches, because they're not making enough energy to keep their real estate space, because they're making tubes too. But if the trunk covers them up, then their circulation gets cut off and they die.
So I have an orange tree that I wanted to maintain the height, so I pruned one of the branches.
Mm-hmm.
And what's happening is the bark is starting to peel off the top. So do you recommend like putting that paint on it?
Not really. We don't really. I mean, if you suddenly expose some green wood on the tree, then yeah, it might be good to paint it white just to reflect the heat, because the leaves were shading it. Citrus, we don't see them burning that easily. Avocados burn, mango trees can burn if you suddenly expose bare wood or green wood like this.
Okay.
This is a camphor tree, which is cinnamon tree, which is related to avocado, but we don't see any burning going on, even though there's a lot of exposed wood here, or exposed bark there. But yeah, citrus. If you were in Riverside, I'd probably paint it white.
I'm in Rolling Heights. It's pretty hot.
Well, it doesn't hurt it. Just with a light colored latex paint, just paint what you expose all of a sudden. But most of these trees that we have, yeah, it's not a big issue. So anyway, so this, when you have a piece of wood and there's a knot in it, that's what this is. The branch that got covered up by the trunk is the knot. Now it's interesting because trees grow really tall, but if it was a true tube, the leaves are pulling the water out of, or the leaves are evaporating the water. There's a suction that's pulling this up. But if you have a tube over 33.5 foot, you can't vacuum pull it anymore. The gravity's too strong. So the tubes aren't more than that length. So they're probably not as long, and they have to transport it to a different tube that pulls the water up, transport it to a different tube that pulls the water up. I don't know the total mechanics of that. I don't know if anyone does yet, because they're still trying to figure out how redwood trees can pull water up 300 feet from the ground, because you'd have to have a pump pushing upwards to get it that high somehow, or just tube to tube to tube, keep transferring it like short elevators to get it up that high. But that's an interesting another topic. Now, so you've got this, let's just draw this now. We've got tubes of wood in the center. So as the tree ages, the tubes just inside the cannulator are very active, and as you go deeper and deeper into the trunk, the older and older tubes that were formed when the tree was young, they become inactive. That's the heartwood. So the heartwood of a tree, you can't really say it's dead, because even though there's nothing going on there, it's not actually dead, because it can react to injury. But it's not, there's no circulation there. There's nothing happening there. So it's kind of this strange thing. You say it's suspended animation. We don't know. But the heartwood's in the middle. The functional wood that sends up the water's there. The bark is in layers out here. Now, some trees, the bark can stretch really good. Like this tree, the bark is stretching it. The original stem was only that thick, but the bark has stretched this far. But you can see down here, it's starting to break up, because it can't stretch that far, because the diameter of this branch keeps spreading. Now, some trees, the bark just cracks, and you get the rough bark on some trees. On some trees, like some eucalyptus, it just splits off every year, and you get the smooth trunk. Cork develops a really deep cracks, and it just stays on the tree, but it gets deeper and deeper and deeper, and that's your cork. So that's So certain plants, apples, the bark stretches really good. They stay smooth a long time before they get rough. So different plants do different things that way, but the bark is cracking because it can't stretch as the tree gets wider. So anyway, we got tubes of xylem in the middle, and then you've got layers of bark on the outside, and you've got your cambium layer in the middle between those two. Now, if you just cut it, the tree has a natural reaction. Now there's different, well, okay, so plants are not like animals. Like if you cut your finger, you bleed, and then it stops bleeding and it starts to heal, so that after a few weeks, sometimes you can't even tell you had it. Well, it sometimes takes a few months. You cannot even tell you had a cut there, because the animal bodies heal what got messed up. Plants don't heal at all. So what plants do is they retreat. So they will form a barrier of dead wood. It kind of caps off that area. They said it's within moments after you cut it that it forms a barrier. So most arborists no longer put tar on this or anything on this to seal it, because the plant already did it. It sealed itself like that. And then when the plant starts to grow again.
So you don't even seal larger branches?
Some arborists still do, but
It's not necessary?
Right. The U.S. Forest Department did all this research, and they said it doesn't seem to do a thing, because the tree sealed itself as well as it's going to seal, and putting bark, tar or something on top of that doesn't seem to do anything. It might impede growing back over the area, if anything. And sometimes it'll seal a rotten area underneath the tar, so it's not really helping. So they said they don't recommend it, although some arborists, some of the older arborists refuse to believe that. They'll still paint it or do something to the wound. But trees, if they're going to seal it, they seal it quite well. So when this plant starts growing, it'll start growing a branch. The cambium layer starts, sometimes they'll do it several places, and then they'll start forming the wood and the bark off the top of that, and they'll grow new layers of bark and new layers of wood that are attached to the wood inside there. But this area is still going to be, it never fixes itself. It's going to always be there. Now, what'll happen over time is these branches will then form a layer over that area, so you won't see it anymore. They'll just keep on layering more tissue over it, but that damage is still in there. Now, the problem we have with certain plants is some plants don't seal very well. So it's interesting, the best sealing plant known to the researchers are apple trees. They said you cut an apple tree, it seals it right there. It hardly has any dead area at all. The worst sealing plant they know of is a close relative to the apple, the peach. They said peaches virtually don't seal at all. So you make a cut like this, you've got a dead area all the way down deep into that plant, that size. It just retreats. You get a big old dead area inside that tree. So among orchards, apple orchards live the longest because, we prune apples to make them more productive and keep them shorter. And there's apple orchards full production for 150 years. The peach is a nectarine. Nectarine's same as a peach. they have the shortest lifespan of any orchard. Now they're going about 13 years. They said after 10 years of pruning them, you're doing so much damage to the tree. Even though they'll remain productive, their production's going down. So they statistically, it wasn't worth keeping more than, they used to tell us 25. And then when they looked at the statistics, they said 13 for a farmer. Homeowner, 25, 30 years, you're still getting enough peaches to keep you fed. But for an orchard guy, 13 years, it's not worth it after that. They said there's too much damage to the tree, so they just cut it down, get rid of it, plant something else. So that's the worst, but there's a lot of bad seedling trees to know. So peach, nectarine, but birches are bad. I remember when I was a kid, my dad had a line of birches that looked like they're too tall for the pot, so I just cut them in half and killed all of them. So birches do not like to be pruned. So if you prune a small damage, you're doing a little bit of damage. If you prune a bigger stem, you're doing a lot of damage. So the skinnier you do the damage, the less harm you're doing to the plant. The thicker the trunk, the worst. And the birch trees I was cutting were about this thick. And that was bad enough to wipe out those birch trees. Generally, if you cut off a branch like this, the plant doesn't flinch. It's just not enough damage. But bigger things. So birches, aspens are close related. Maples aren't supposed to be all that great either.
What about figs?
Figs can live a long time even when they're pruned. So I don't. The ficus family seems to be a real long-lived family. I mean, there's the tree that Buddha was enlightened under that was relocated to Sri Lanka. They said that tree's been there since, what was it, 1200 BC? I mean, it's been under guard. They've cultivated a tree that people have been taking care of for that long, and that's a ficus. So we know ficus live a long time. Apricots are, stone fruit in general are not. So apricot trees 20 to 30, plum trees about the same. So they're not the stone fruit trees. Cherries are the longest lived among stone fruits, but we don't prune them as much. They said a peach tree should live 200 years if man never touched it. But we have to, if you don't touch them, then they don't produce as well. And they're too tall, so.
Yeah, my branches break because the peaches are.
Right. So anyway, they retreat. Now the other thing to know is plants are all guided by hormones. So the growing tips of they call this the apical bud, the bud that's at the very tip of the branch, ready to make new stem and new leaves. The bud's there, and then at the base of each leaf, there's a potential bud to grow too. So let's talk about that a little bit. So on a branch, wherever a leaf is attached, there is a node there, which is a slight bump on the stem where the leaves attach. So those are nodes. You can kind of see them on these leaves. There's a little bump coming out with the leaf on each of those. There's little bumps on each of these. And there's a potential bud in there too that'll grow a branch from the base of that leaf, as well as the bud at the very tip of the branch that's going to make more leaves and more branch also. So it's all done by hormones. So all these buds are creating a chemical hormone called, we just call it in general auxin. There are chemical names for those hormones, but they're too difficult to remember. Naphthalacetic acid and some the different kinds of hormones that they send down, and and the hormones travel by gravity. So this hormone here, and what the hormones do is they keep these side buds from sprouting. So each leaf and the tip of the plant, they're sending hormones down the stems to keep the side branches from sprouting. And generally, after a while, the hormone is so diluted that the branches start growing. The buds on these side leaves start growing, and then you see this branch come out. So this is, they call it apically dominant, when this top bud can stop a lot of this stuff from going on right below it. And that's how most trees are. Most trees, the top buds prevent a lot of sprouting close to them, whereas the bushes, they don't. So bushes, they grow a few inches, they start branching. They grow a few inches, the branches start coming out from the nodes below them. Especially like this one, where you can see just, half an inch from the tip, it's growing a side branch already. So bushes generally are not apical dominant. The tip is not the dominant place, and they branch really, really readily, and that makes more of a bush. So when you're cutting, okay, let's turn the page. So a lot of references mention there's two kinds of cuts, a heading cut and a thinning cut. It's not really that complicated. So you got a stem with branches down here, and it's got the apical tips like this, like this, like this. So this is preventing sprouting from in here. These tips are preventing sprouting from down here. If you cut the very tip of that branch off, which is a heading cut, then the tip is suddenly gone, and all these nodes in here that were being kept quiet by this one are suddenly active. And so you cut that off. If you cut that off, then suddenly all these nodes start waking up, and you get branching like that. So you get a fuller plant. A thinning cut, if you cut this branch off right here, then the apical dominance coming off of these branches and this one prevents anything from regrowing in that area, so that this area is now thinner. There's less foliage there, nothing's going to sprout, because all these other things are sending hormones down to stop it. These branches, this branch. So if you just cut this branch off totally, then it doesn't regrow. But if you cut the tip off, yeah, a whole bunch of things start growing. So that's a heading cut. This is a thinning cut. You're making it more open. This one, you're making it fuller. But it's, it's still just a pruning cut. So if I cut one of these branches off, it probably won't grow back. But if I cut this off, then you probably have all these leaves. I'll try to send a lot of times you suddenly remove the top, and all these suddenly start opening up and growing branches. Although the one at the top sometimes shuts them down. The one at the very tip of the branch, if it grows fast, then a lot of these just stop growing and sometimes even die because of the influence of the one on top. Okay, let's see. Okay, on a tree, let's draw a tree again with a branch on it. So here's the heartwood. Here's the bark. And let's put a branch on this tree. So the tubes running to the branch are not the tubes generally that run up the rest of the tree. Those are separate tubes. So it's almost like all these cables coming together in the tree. And then you got the bark on the outside. And on a typical tree, the bark from the branch and the bark from the trunk collide because they're both growing. And you get what is called a bark branch ridge. And you can see it on this tree, maybe, where this branch and that trunk, there's a line there. And there's a line here where the bark of the two are colliding. This one's interesting, it's more typical. It's slanted slightly in. I don't know if you can see that very well, and on older trees, it's really big. I mean, this can be sticking up several inches, so you can see it. Even on this one that died, you can still see a little bark branch ridge there. And on my house, I cut down all my big trees, so I don't have branches to bring in of a big size to show you the bark branch ridges. But all plants pretty much make them, except for ferns. So this is bark from this branch. This is bark from the tree trunk. They're colliding right there. We also know that the wood from this branch here doesn't go above that bark branch ridge. All the wood heads into the trunk and it kind of mingles with the wood of the trunk, but it's separate. So if you want to cut this branch off, now the other thing to watch out for is that the wood from the trunk actually does something like this. It forms the little collars there. So it's actually going underneath that thing. So if you want to cut off this branch, they say what you do is you go to the edge of the ridge and you make imaginary line going straight down, and then you make another line going outwards the same angle as the bark branch ridge, and that's where you cut it. Because if you go straight down, you're going to be damaging the wood from the trunk, which again does that. And you'll cause the tree to retreat into the trunk, so this big dead area inside the trunk. If you cut it right here, you'll just cause a dead area where this branch goes like this. You'll have a dead area about that size. But if you cut too close to the trunk, which they used to do in the old days, so back in the 1800s, early 1900s, in fact, when I first started, they said, cut the branch off as close as you can to the trunk, because it makes a smoother heel over it. But what they didn't know is that they were damaging the tree inside. Whereas if you leave a little bump there, then there's no damage to the tree that you left, just to where the branch was connected. So that's how we do it now.
Gary, so if you cut.
If you cut then on the outermost, you make that outer cut, and then it dies back.
Yeah.
Then once it's died back, then do you cut it so it heals better, or you just never cut it?
Just never cut it.
Okay.
Yeah. Because the tree is all sealed up. So the worst thing you want to do is recut a wound. So when trees do this plugging and healing, or sealing, we call it sealing. When they seal a wound, they can't do it twice. They're programmed to seal it once, and then that's it. If you were to go to a place where someone's cut a tree and cut right below it, it's got trouble sealing that area again, so it has to retreat much further down the trunk to an area that hasn't been touched before and seal it there. So they said, don't mess with, if a tree cracks funny and it's leaving a lot of jagged pieces, it's nice to clean those up, but don't recut it because the tree can't seal it again. So, okay, so if you're cutting off this branch, you cut like that, and then if you cut too far out, it'll regrow. That's the problem. If you cut it out here, then that branch just grows back. But if you get it cut right to here, it can't regrow. So that's the reason we cut it right at that line. Now, if you want to save the side branch and cut off the main one, we go right down the bark branch ridge. You just cut it right along that ridge line. So you haven't touched any wood from this branch at all. So the branch is intact. You've cut this off. It can't regrow either because it's being influenced by the hormones coming down this branch. If you leave this thing too high, then it regrows branches off of that. And if it's a big trunk, the problem we have is it takes years to develop all the strength of the wood. But a lot of times, like if you top a eucalyptus tree, it'll grow over 20 foot in 1 year, just 20 foot of growth going straight up. And it's attached one layer of wood and one layer of bark. 20 foot of growth. Those things break off real easy because they've only got 1 year of attachment on them. Or even 2 or 3 years may not be enough to hold that branch in place. This is already full strength. So cutting it to a lower branch, there's no problem with the strength of the tree. But if you top a tree with a trunk this big, it's got so much energy. It wants to grow those branches back in 1 year. Well, there's just not enough strength in that joint that's connected to hold it. So these just break off. So they don't want you to top big trees for that reason. You cut it, you lower the crotch to a side branch. You lower the tree to one of the side branches. So.
My dad had 5 or 6 50 or 60 foot redwood trees and was concerned, and he had someone come and top them, took off the top 20 or 25 feet. 2 years later, during a big windstorm, the new growth on almost all of them blew right off.
Right.
Each of them sent up 2 or 3 new things, and they were growing 6 or 8 feet a year. But all it took was one good windstorm. So this finally explains why that happened.
Right. Now, all we're talking about at the moment is mainly for shade trees. When you're pruning a bush or a fruit tree, we aren't concerned much about them because if a branch breaks off, no one's going to die. House not going to get damaged. But it's mainly for the bigger trees. We have to treat the big trees carefully because they're dangerous if they fall on us. So all these rules kind of go out when you're talking about smaller plants. But anyway, that's the reason. Now, just quickly, we'll go over the strongest shapes in nature. Someone bought one of my samples here. So one of the common shapes of trees that's pretty strong is a vase shape. So maples kind of do it. Maples are weird in that whenever they branch, they go from 1 to 3, 1 in the middle, 2 on the sides. So they have this is called opposite branching, that's a weird thing that they do. But the pink trumpet tree that was in here and red bud trees do this too, where they go from 1 stem and then suddenly they branch to 2, and they branch to 4. And so on 8. That's a perfect. Yes, that's a perfect vase. It's a pretty strong shape. 1 to 2 to 4 to 8, all that. but they consider the strong shape, and the biggest trees do what is called a delayed vase, where they're going with one central trunk, and then it branches like this to one side, and then it branches like that to another side. So it's essentially a vase, but there's one stem that stays in the middle. And I've actually taken these and trained them so one stem stays in the middle if you want your branches to be higher on the tree. So you just bend it so it's all straight up. But the delayed vase is the strongest shape. This tree is doing it where the branches are occurring. Ideally, you want it to be a spiral around the center trunk. It's not perfect, but this tree is pretty close to being a perfect delayed vase. Generally, that's how because walnut trees are huge tree, over 80 foot tall. So we want a delayed vase, so one center trunk, and then the branches kind of spiral around that center trunk. Now, this is not perfect at this time, because on a walnut, the main trunk is like this, like this, and the side branches are this big. And you can see here, if these side branches are 1.5 feet in diameter, there's not enough room on this trunk. So what they tell the farmer to do is you keep watching it as it grows and select the branches. Now, a lot of times, a lot of these will just die and fall off because the trunk is too strong. But you select the branches to be at least 1.5 feet apart up your trunk. So it's nice to have one on this side, then this side, then this side, and that side, all the way up the tree if you want to make it perfect. But space them. So like this will be one, this is probably might be a permanent branch, and then one up here may be the next permanent branch on this tree. As it gets older, all this other stuff is too close. It may just fall off on its own. If it doesn't, you take it off probably in 2 or 3 years, since they grow about 4 or 5 foot a year. So you kind of train it as it goes. Now, conifers like pines have a totally different method, and it seems to be okay, even though it seems to be so crowded. So if you for all yes.
We have a magnolia tree.
Mm-hmm.
It's very big, and it's in the middle of my chicken coop, and it's not doing well at all. There's a lot of dead branches on it. And we have a influx of mice. We've got that kind of controlled, but are the mice killing those new branches, or is something going on with that tree?
Yeah, I haven't noticed mice or rats eating magnolias. We've seen them eat apples, and we've seen them eat plants that we thought were poisonous, but I haven't noticed them eating magnolias. But I don't know. They might.
Well,
We've seen them eat citrus and roses.
Help that magnolia tree to trim all that dead stuff away?
It does help trees to prune dead stuff. Now, the one thing to know about pruning dead wounds is a lot of books will tell you to cut below the bad parts, but what the forest department says, they said if you see, like here's a branch that died to, this is not a good sample.
These branches they no longer have any leaves. At one point they did.
Yeah, they said if you have a branch that say is definitely dead because it suddenly changes color and size, so it's dead there and it's live here, don't cut it into the living part. Just cut it as close you can to the living part through the dead area, because that's already sealed. If you cut into the living part, then it's got to retreat again and seal again. So you just kind of cut close to the living part, but not into it.
No, the issue I think might be being eaten. Can they eat them?
Well, I wouldn't put it past a mouse.
They're tearing up their orange juice.
Yeah. Now, for rats and mice, try the bubble gum trick first. See if that gets them. Yeah, if rats or mice eat bubble gum, they don't like minty gum, but bubble gum is fruity. It kills them. If they eat it, it kills them. It's weird that it works, but we finally tried it after thinking about it for years because someone told us about that. So my daughter put out bubble gum, just unwrapped it.
Field rats?
It may, yeah, it should. Yeah.
I think I'm gonna go get a pack.
How do you get the mice to eat it?
They think it's food.
Pardon me?
They think it's food. It's got sugar.
I mean, you put it on the tree or you just put it around?
We just put it on the top of a block wall, and 3 days later I go walking around the wall and there's 2 dead mice, 2 dead rats, and a dead mouse laying at the bottom of the wall. I'm going, okay, that worked fast. So
I got a field rat I want to say goodbye to.
it doesn't work on squirrels, unfortunately, but it works on rats, mice, and I've been told gophers. I've never tried on a gopher.
Pellet rifle works on squirrel.
You said it does or doesn't work on squirrels?
I can cover the pines. I've got a large, like a 100-foot pine tree that's 50 years old that's trying to lean at the top, and it's a concern of mine. So, are you going to cover, are pines any different than the other, pretty big size?
That's a good point. So among the trees, see, most trees, you cut it to a bare part of the tree and it regrows. On most trees, the bark, even when it's old, it's got growth buds still active on it. Pines in general do not. So if you have a pine tree and you cut it to a portion of the wood that's now has no needles, it never resprouts. So we had a case at our old store in Lake Forest. A young kid trimmed all the condominium pine trees to stubs, and none of them regrew. He was forced to replant all the pine trees in the condominium because he didn't know that if you stub a pine, it doesn't regrow. Junipers do, but not pines. There's one pine that does. I believe Monterey pines will resprout from bare wood, but all the other pines, if you go below the last leaf on that branch, it can't regrow. The growth buds are active where there are needles, but not below the last needle on that branch. I mean, you can lower the tree to a side branch with needles on it, and that's fine.
Right.
But if you cut off, even on the side branch, you cut it to a bare area, it doesn't resprout on most pines. A lot of the myrtle family is the same way. So I brought this in because if you did that to this plant, cut it to a stump where there's no leaves left, it won't regrow. Eucalyptus do. So even though eucalyptus are related to this, eucalyptus will resprout. But a lot of plants, proteas, I brought a protea in here. I thought, here it is. So proteas, macadamias, which are in the protea family, resprout if you cut them to stubs, but the actual protea itself and leucospermums and some of their relatives, if you cut them to bare wood, they no longer grow from that branch. So,
If you top a Mexican palm, will you kill it?
yes. Yeah, palms don't resprout. There's been a few cases where they do, but it's very rare that they resprout from a stump.
When they're little, it's like they're immortal, but when they're bigger, that would be the end of them, huh?
Yep.
Okay.
Okay, so
I guess it's just time for a shave.
on fruiting trees, the main theme on fruiting trees is they will fruit from an area that had leaves last year. So they fruit on second year wood.
All fruiting trees?
Except for one. But so this tree grew this branch last year, and it could have made flowers on that branch that grew last year. Now it's making fruit here. So this was a branch that grew last year, and the very tip of it, which was probably pointing upwards, was getting a lot of sunlight, so it made a flower bud right at the end, or a group of flower buds right at the end of that branch. And now that the apples are forming on it, this branch is going to hang down. But they form on year-old wood. Now, apple trees are a little different. So peach trees, I should have brought a peach tree in here. So peach trees will grow a branch this year, and that entire branch will bloom along its entire length next year. And then after that, it branches off that branch. That same section never ever flowers again. But the branches that grow off it then bloom, and then they'll fruit too. So whatever grows this year, whatever has leaves this year, can potentially bloom next year. So peaches happen to make a flower bud at the base of each leaf that on the branch, and then the next year, those nodes make flower buds, and they'll grow branches out of those nodes too. But the peaches are right there. So they bloom off of second-year wood that grew last year. Now, the one fruit tree that is an exception to that is jujube. So jujube trees flower on new growth, kind of like modern roses do. So modern roses, you can cut them all the way to the stubs, and whatever grows will bloom at the end of that branch. Jujubes are interesting trees. You can cut them to a stump every winter, and they'll grow new branches that come up, bloom, make fruit. They said in the poor third world countries of Eastern Asia, it's a very valuable tree because they can pick all the fruit, use it for food, sell it. They can pick off the leaves 2 weeks after the fruit and feed them to their cattle. They can cut the trees down in winter, make firewood out of them. So they said they use the entire tree. I mean, I had to try it. So back in the 90s, I had a jujube that was a little taller than I can reach. So I cut it down to about 18 inches, which is shorter than they do, and they're supposed to do. It's supposed to be like 4 foot. I cut it down to 18 inches, and by July, I was back up to here and full of flowers again and fruit. So that one can do it, but most other fruit trees, if you go beyond where the leaves were, like on a citrus tree, it's just a real bushy thing. But as long as you're trimming it and there's still leaves on the branch, that was last year's growth. Then grow new branches with flowers on them. It's like peaches, the flower comes right off the branch. But a lot of these fruit trees, like mulberries and figs, the fruit comes off of the growth that comes off of 1-year-old wood. So mulberry, as long as you leave some 1-year-old wood on the tree, it could be that much, the branch that's growing off that 1-year-old wood will bloom and make fruit. And same with figs, and same with grapes. You leave a little section that grew last year, and the branch that grows off of that will have the fruit on it. Whereas this apple, the flower is coming right off the end of last year's branch, and the peaches, they come right off the branch itself. But that's the rules on fruit trees. Now, in the old days, when I first started growing fruit trees, the proper way to shape them was into an open vase. And that's because fruit trees kind of do that naturally. When fruit trees grow, a lot of times they go branches straight up. When they're growing straight up, the only place in the tree that's getting enough sunlight to fruit is the very tops of the branch because it's straight up. But as it grows higher and higher, and these get longer and longer, they tend to bow outwards by their own weight. And then they start making all these short branches in the middle that then fruit also. That was the old days, because what was happening, like on peach trees and all that, they said it took 6 years to create a nice open tree. So you spend half the tree's life creating the shape. So now what we do with fruit trees is we tend to make them a lot shorter and a lot narrower and force the branching to go outwards rather than up. You just have to force them, make sure they're going outwards, tie them down, whatever. What they found is that these old trees, because they were so dense with foliage, that the area of the tree that fruited was pretty much this area here. And this was all wasted space. If you can keep a tree only 5 foot wide and say 8 foot tall, the sunlight makes it through the whole tree, so the entire tree is productive. Whereas this, it's a shallow fruit around a dark area, and a lot of times the middle doesn't have any fruit at all. So even though you get more fruit on this size tree, you don't get as much fruit per square foot. And what you've got to do in your yard now, and with modern trees, is just plant more trees. In the same space of one big tree, you can probably do 4 or 5 smaller trees and get more fruit off the smaller trees than you would with one big tree.
Yeah, I've got a Granny Smith I let kind of grow on its own, and it fruited throughout the whole tree, even when it got a very thick leaf canopy, but I eventually had to get a real long picker to get the fruit. So that would have saved quite a bit.
Yeah, so the typical way to do apple trees is one central leader, one stem going straight up, and then all the branches being bent horizontal in Christmas tree form. Everybody knows what Christmas trees look like. So you keep on, you like this has got this one here, so we'll train this one straight up, and then we'll train a lot of these little branches horizontally and keep going up to about as high as you can reach. And then what happens, so I forgot to mention when we're training big trees, they have certain angles they work with. So let's say you've got a big oak tree or maple tree. The branching you want on it, you want it to be above horizontal, but not too much above 30 degrees or so. So right around 20, I don't remember what the correct angle was, but ideally around 28 degrees off of horizontal. You don't want it to be too vertical, because if the branch is too vertical, then it tries to act like the center trunk. And you certainly don't want any branch to come right off like this. So if you have a narrow fork in a tree, the problem with that is the bark and the wood can't form between the two. So it is a weak area of that tree. Now the forest department is not as scared of those as they used to be, because they said they've seen a lot of huge trees that are joined together like that, and they don't fall over because they've got enough wood on the outsides. They say the danger is if you have a tree joined together and one is a lot bigger than the other, and you see the ridge going to one side, then you know that one's about to fall off. It doesn't have enough wood to hold it on. If the ridge goes down the middle, it's pretty strong. But if it goes off to one side, then take that one off, because it's not getting enough wood to support it. But they're not as fanatically removing the sides from fork trees as they used to, because they're not as dangerous as they thought they were. But you don't want a central leader to have, I mean, it's not a big deal on a fruit tree to have 2 leaders or 3 leaders going up. But on shade trees, we don't want that central leader. So anything that's too vertical, you cut it off. And if it grows too flat, what happens to branches that grow flat is they no longer grow that way, but they start a lot of new growth that does this. And that messes up the tree's look totally. So you don't want the horizontal branches. Now, some really old oak trees do this and they don't sprout out anymore. It's not a big deal, but But on most younger trees, if the branch is too horizontal, then they all try to make central leaders coming off of them, and that's not good either. So they like it to be upward slightly, but not too straight up. And that's, again, on the big trees. Of course, most of us will just hire people to go 30 foot up in the air to do that stuff.
For the fruiting trees, is there a better time of the year to prune them than
Oh,
another?
that's really good. I forgot to mention that. So when trees have their initial new growth, they've used up all the energy reserves in this part of the stem. It's pretty localized. So this part of the stem, if you cut this thing right here right now, it can't seal very well because all the energy has been used to make those new leaves. Now within a few more weeks, it'll probably have its energy back. So it has to regroup the energy. So right when they're just starting to sprout, all the new leaves coming out, this very new leaves coming out, that wood there can't seal very well for a while. And then by mid to late spring, it gets its energy back, and then you can cut. So the only time of year that's really bad to cut trees is right when the spring growth starts. Now some trees started in January, some start in February, so you have to go with the plant. This one actually has been growing for a month. So it's probably pretty close to being ready to seal wounds here again. Now, in the old days, they always said prune in winter because the trees didn't bleed in winter. They thought that was better if the tree didn't bleed. But now they know that the sap coming out of that wound is the tree's protection from bug attack. So, like in a mild climate, well, we still don't have that many bugs in winter, but in theory, you want the sap to keep the bugs from getting into the wound. That's one reason they have that sap coming out. So they say prune for health of the tree. You can prune winter because it's at full strength, and hopefully you don't have any bugs that'll attack that wood. You can prune summer, you can prune fall. Now, if you have a fruit tree, we don't like to prune the fruiting wood in winter or fall because you're cutting off your wood that's going to fruit if you're doing it at that time. So usually with fruit trees, we like to prune in the summertime. That is most of your size control. So if you have a peach tree and you want to keep it from getting over 8 foot, do all that work in the summer because they haven't. Okay, I'm going to backtrack a little because I didn't tell you. So most plants, especially deciduous plants, they grow in spring and summer, and then they stop growing in the fall and store energy for next year's growth. Tropical trees may not do that. They're not programmed to slow down in the fall, but all your deciduous trees, maples, apples aren't quite as good at that, but peaches, nectarines, they grow spring, they grow summer, aren't saving much energy at that time, but come fall, they stop growing, and then all the branches start making flower buds where they're supposed to be for next year's crop. So on a fruit tree, if you cut it, you can cut as much as you want in summertime, and you're not cutting off next year's fruit production. But come fall and winter, especially late fall and winter, whatever you're touching is going to be already has the flower buds there. Now you may not need it, but generally just note that the best flower buds on most fruit trees in the winter are the ones at the very top that had the most sunlight. And if you suddenly start bringing your tree down in the winter, you're cutting off your best flowering wood, fruiting wood, and you're leaving what's left on the bottom, which may be, like on a peach tree, it's ample. They make so much fruit that it's ample, but just be aware of that's what you're doing. You're not hurting the tree, but you're hurting your crop. Wintertime, we do mostly cutting off of areas that you don't want. You don't cut branches that you expect to fruit, but you're cutting off branches that you won't like the peach trees. What happens is they only fruit on that branch once. Uh-oh. So say a peach tree he grew this branch, and then that one fruited, and then from that branch it grows more branches, and then they'll fruit there, and then from here they'll grow even more branches the next year. So if you're doing this and keeping the branch, you'll have to let your peach tree grow bigger and bigger every year to get fruit on it. But what they do in orchards is once this branch fruits, they'll cut it off. They'll cut it short, not cut it off. And the next year it regrows. So on a peach tree, a lot of times there's a lot of peaches have a lot of branches. You'll keep this branch, you'll keep this branch, you'll keep this branch, you'll cut off that one that fruited already, you'll cut off another one that fruited already, and then they'll regrow the following year. And then you do the opposite. You'll cut off the ones that fruited, and then you save these that grew back. So it makes, peaches are kind of complicated. And you can see you have to do a lot of pruning on them, which kills them, you know. But they say the best fruit on a peach tree or nectarine are the branches that grew that year about 1 to 2 foot long. Those are the branches you want to keep. If the branch grew 3 feet, there's very little flower buds on it. Spent too much energy growing. If it's this long, then it doesn't have enough energy to make good fruit. Although usually it's good enough for homeowners. But if you're trying to grow supermarket fruit, you want it to be that size, you've got to have a longer branch. Although again, for homeowners, it's not that big a deal. The short branches of fruit, good tasting fruit too. But if you want maximum quality, you thin out your growth that way. Whereas on an apple tree, what they do, so this is a real short branch here. It's only, what, 1/8 of an inch long? And that can make a flower bud next year. And this one too, this branch is only, what, about 1/2 inch long here. But this can make a flower bud too. So what apples do is when the branch falls over, when the branch is upright, the only flower buds that form are at the tips, like this one. But once they lay down to the side, or you lay them down, then they start growing all these little branches off the side of that can make flower buds. Now, sometimes the branch will take off and grow straight up, and then you just keep clipping it close to that branch. If you keep clipping it there and there's still leaves there, then in the fall, that stops growing too and makes a flower bud on it. And then you'll have your fruit loading up on the side branches. The branches on the tips tend to sunburn easy. The branches on the bases of the branches, these are all called fruiting spurs. That's your best quality apples. They're not hanging out in the sunlight. So apples, pears, plums, apricots all have little short branches in the interior of the tree that make, so just shorter branches that make flowers and fruit. Whereas peaches, you got these long things. I mean, plums can make flowers on their long branches too, but they make a lot of short branches in the interior of the tree that make real good fruit also. Yes.
We shouldn't be concerned about the weight of the fruit when it's going a lot.
Oh, yes. Yeah, so on peaches, you're cutting off 80% of the crop, because if they're, the peaches had leaves that were that far apart, and any peach that's that close to the next peach, that's about as big as they grow, about as big as a golf ball. So the apples, if you let these 4 apples develop, it'll break that branch off. If you leave one apple on there, this branch should be able to hold it. So.
I have a loquat. Would it be similar to plums? How they react to
Loquats, whatever branch grows this year will flower at the end of it next year. I've actually cut loquats totally to a stump right after the fruit was off, because they were getting too big, and when they grew back, they bloomed again on the ends of the branches. Okay. But you can't be too late on that, because then you won't have enough energy. But a lot of times they'll just tell you cut the longest branches back, leave the shorter branches intact, and you'll have enough fruit. But I one time cut the entire top off, and it still had enough energy to fruit the next year again. Okay, on roses, they used to print pamphlets on how to prune roses properly. So like this is a hybrid tea. We're not supposed to have this many flowers on it, but it made it. You're supposed to cut down to the first 5 leaflet leaf after that that flower is done like this. You can see on this particular branch here with just 1 flower on it, the first leaf has only got 1, maybe 2 leaflets, you can call that. This is 3, this is 3, this is 5. So they usually want you to cut it down to the first 5 leaflet leaf that's not facing inwards, which would be this one, because that'll have more energy to make a flower of good size. So they used to have all these rules on how to shape it, prune it, all this stuff, until in England back in the 80s, at that time, roses were not as popular as they were before the late 80s. So they were experimenting with machine pruning. And the rosarians said, no way that the machines can prune a rose as good as a human. So they actually ran a test. They had 50 roses that the best rosarians in England pruned, and they had another bed where a machine just automatically cut the tops off. And they wanted to count how many quality roses each side has. The same. And they ran the test. They said, no, it can't be. They ran the test for 5 years, and it never came out any different. So now they have instructions on how to use chainsaws to prune roses. Because apparently it doesn't make that much difference.
Rose is tough.
Because they weren't able to prove that humans did a better job. But I mean, we do want you to take off the spent flower, because it does take some energy to make the seed pod. If it makes a seed pod, then energy is spent doing that.
So after it blooms, oh, sorry.
Where do you deadhead a rose?
You just cut the flower off.
Doesn't matter how far down.
Apparently, it doesn't matter how far down you cut it. Now, a florist will tell you different. So the florist will always cut it down to the last 5 leaflet leaf on the branch, because that'll force the rose to grow a longer stem. And the longer the stem, usually the bigger the flower. So florist roses are different. They want the longest straight stem and the biggest flower, and that'll be cutting it the lowest on that branch. But on that branch, not to an older branch, but on that same branch. So and if you're in Minnesota, you don't trim your roses at all, because you only have 3 months, 4 months to bloom. So you don't trim anything really. So roses, all the stuff that we learned about roses doesn't really matter. Now what's interesting though is that 20 years ago, a guy working at the Huntington Rose Gardens decided he would trim all the roses like English roses. So English roses with 100 petals on them, those real full flowers. David Austin, who kind of made the English roses popular around the world, he said, don't trim our roses for at least 3 years. Don't trim them. And the stems would get about that thick. And so the guy at the Huntington Garden says, well, I'm going to do that with the American roses. And he did. And what was real interesting is that when you let the stems and roses get that thick, they get more petals. So I went over there in the early 90s, late 80s, and looked at the roses in the spring, because they said, oh, they make 5 times many flowers that are spectacular. And I looked at them and go, I don't recognize these roses, because they had double light there, and it didn't look like a double light at all. It had like over 100 petals on it, and you couldn't see any colors on it. Going, this does not look like the roses in her catalog. This rose would have just been a mess of red petals. So the thicker the stems, the more petals they get, and the more English they look. But you don't get the nice spirals that the classic American roses have. These spirals where they only have 30 to 40 petals that spiral nice. If you let the stems get that thick, then they have too many petals. So it's real interesting. I'm sure the rose would rather have a lot of petals, but it doesn't fit what we want to see. Yes.
Risk a silly question here. What made the difference between that droopy rose stem and the strong one?
This came off. This was entirely new branch that came off the base of the plant. This was coming off an older stem. That one isn't as strong.
Because that one and that one, they seem so similar, except for that one's really droopy.
Right. Well, as roses get going, like this one, apparently just grew maybe a month ago. Month and a half. Takes 6 weeks to make a flower from new growth. Yeah, they're definitely stronger as the plant gets more energy, more leaves on it. Like I used to grow one called White Masterpiece, and the flowers were really big. So the first year that White Masterpiece was just ground cover, the stems couldn't hold up any of the flowers. They're just laying on the ground. Second year, they can lift themselves up because the stems were stronger. So as they get stronger, they get stiffer and more upright.
If your roses start to have yellow spots on the leaves, what does that mean?
Disease.
Oh.
That was a class 3 weeks ago.
Yeah. Question here.
Yes.
On the roses, could the extreme temperatures we're having, like this last couple of weeks, we were like in the low 60s, and then we hit 90s yesterday. I had some roses that were actually burned. It looked like somebody put a torch to it on the petals of the roses.
We haven't seen that.
Oh, wow. It was on
Um,
more than one rose.
yeah, I don't know. Well, I mean, okay, so if you get rain, raindrops fall in here, it rots the rose from the inside and never opens, and it browns on the outside. And there are some roses that have too many petals, like we used to carry Miss All American Beauty. Too many petals all stick together, and all it does is brown out and it falls off. It never opens until the air dries up. Like this heat would have opened it up, but during cool, humid weather, a lot of roses can't open. They have too many petals. English roses open because they're not all spiraled up like these are. So I bet you it's the rain, because the rain will cause a lot of roses to turn brown on the thing. But that's a different subject too. So here's hydrangeas. Now hydrangea, the traditional hydrangea blooms on second year wood. So you can see this is branch grew last year. It's a different color. That stem has a flower on it. This branch is growing from the dirt, no flower bud. So when you're pruning hydrangeas, generally you don't want to prune them too far down. In fact, on hydrangeas in the winter, so if you look at a hydrangea branch in the winter, it's got pairs of buds where the leaves were attached. And the buds at the top are bigger than the buds at the bottom. And what we know about hydrangeas is the big buds at the top will make a branch that has a flower on it. The small buds at the bottom will just make branches with no flowers. So make sure you don't cut them too far down in the winter. Now you can cut a hydrangea, after the first bloom, you can cut them all the way down to here, and whatever they grow in the fall will then have flower, then can make flowers next year. So a lot of people who grow hydrangeas cut them down real short in the summer after the first bloom's over, so they won't get taller and taller and taller. And then they'll regrow branches in this area, and then they'll leave those alone because those will have flower buds on them for next spring. Now they do have hydrangeas that will bloom on new growth now. So far, they haven't been quite as nice as the original hydrangeas, but they're getting close. So there's Endless Summer, and there's the one called Game Changer that will make flowers on new growth, just like roses do. Roses grow flowers on new growth. So everything's getting all jumbled up. Like this week, we advertised 2 Philadelphus mock oranges. The original ones, like Fallbrook, bloom on last year's growth. The new one, called Pearls of Perfume, blooms on last year's growth, and then whatever grows off those branches this year will bloom again. So it makes it a little more exciting. Let's see, anything else here we have? Any other questions? Say now, yes.
Pomegranates. And
Well, they bloom on last year's wood, but there's so much wood on a pomegranate. You can just hack that thing, and there's still branches that had leaves on them. So now, what they're doing with a lot of big trees that are shaped like big balls, like orange trees, pomegranates, avocados, things that were originally trained to be huge balls, is they know that the light only penetrates 3 foot into that. So from the top view, here's your trunk in the middle. What they're doing with a lot of those trees to make them more productive than just one shell of a tree, they're lobing them. So there's more sunlight getting into the tree. And I've done that with my own pomegranate trees. It's a big round thing. So I just started cutting branches so that the light can get further in. We've seen that with modern citrus orchards too. When they didn't train them small, they would just lobe them so that more light gets into the center of the tree. So that's something else you can do.
Does watering harm them?
A different subject.
Because I watered the pomegranate tree the next day, like 5 flowers fell off.
Not the water. Lack of water will make them fall off. Pomegranates is basically what we notice. The more heat and sun they have, the more flowers produce fruit. If it's cloudy, they'll abort a lot of stuff. But if it's sunny, they have more energy, they'll make fruit. But you need a lot of water. We know pomegranates can sit in water. I had a pomegranate sitting in water for 3 months after a real bad rainy season. It did really well, sitting in water. So they're okay that way. Yes.
Are climbing roses any different than regular roses?
They still, well, okay, there's some roses that we sell that act like fruit trees where they only bloom on last year's growth. And all roses will bloom on last year's growth. But some climbers don't bloom on new growth. So you want to keep the stems long on some roses. On some roses, they don't care. Like we know a lot of the modern climbing roses, they act just like bushes. They'll bloom on new growth. Of course, you might want to leave them long because that was the idea, to cover a fence or something. So you just leave them long. But a lot of the older climbers, they don't bloom on new growth. They just bloom on old growth, like Cecile Bruner, I guess Lady Banks. Whatever grew last year will bloom this year, and then that's it. Whatever grows this year won't bloom until next year. So you have to kind of know every rose is a little different. So, any other questions today?
I'm going to step off to work on time. Thank you so much.
All right.
Really, really great.
Thank you.